right, so on your sheet, will you go down to where the little hand is that I pulled off Google and write your reference angles? So if you don't remember which one is the pinky? 0. Okay, the thumb is pi halves. Okay, then your middle finger is pi fourths. Then this one is pi thirds. And then this is pi 6. Okay? The other thing that I want you to make a note of is that if you are not doing one of those original 5 fingers, you need to remember your ASTC chart. Okay, so I'm going to kind of put that maybe down here. Okay, remember it's A, they're all positive. S, only sign is positive. C, no wait, T, crap. E, and then C. So this would be tan positive and cosine positive. Okay? So remember, that helps you remember if you're not at one of the original 5, thank you. Then that'll help you figure it out. Now, this cheat sheet, like I said, is all the way till the semester exam. So we've only covered the first 3 trig derivatives. So don't scratch these out, but they won't be on your test because we haven't covered them in the notes yet. We'll cover them eventually, but for this test, you don't have to worry about those 3. Okay, if you are looking for sine, remember you're going below the bend. Cosine is above the bend. Remember, you're always square rooting over 2. If you need a secant, you are going to find cosine flipped. When I say flipped, I'm referring to like flipping the fraction. So I'm going to also write reciprocal. Okay, but remember, you would find whatever the value is, then just flip the fraction. CSC is which one flipped? Sine flipped. Yeah, so let's say that your sine is a half, then your CSC would be 2 over 1. Okay, tan is sine divided by cosine. Cotan is cosine divided by sine. Okay? And then remember when we did examples on this that we talked about, okay, when you're dividing fractions with more fractions, you're going to keep change flip. Okay, now I will say most of your test is not trig. So if the trig part of this is going to stress you out, let's just take a breath. There'll be probably 1 or 2, but you're not going to fail your test because you can't do every single trig thing that we've talked about. Okay? All right, let me draw your attention to a couple of other things on the front of your sheet. Okay, ln, the derivative is 1 over x. E, the derivative is its own self. You should know those 2. Okay, then up at the top. Okay, let me move up to the top here. Okay, you have your power rule. The derivative of a constant is 0, and then I don't know how I copy pasted this, but I mean, it is true. It just doesn't really go there. Okay. Your advanced derivative rules. Remember, x's on the bottom are going to need a negative in their exponent. Remember that a square root is a half power, cubic root is a third power. Okay, and if you have both, it's power over root for the fraction. Okay, if you want to write that in. Okay?
I've never noticed that. Like, this is how I see, right? And then this is how maybe he sees with glasses.
Yeah, that's
like, you know, when I put these on, is this how he sees without glasses? You know?
Yeah,
that's how it works.
Yeah, pretty much. All right, go ahead and turn the page. Okay, backside. Like I said, sorry, I meant this star to be filled in, but I forgot. So let's write them down. Okay, to check if something is differentiable, The first thing it has to be is continuous. So your limit, x approach a from the left, needs to equal your limit as x approaches a from the right. Okay, after you check your left and right limits, you want to check your y value. Okay, and really the rule is just that you have to have one. Okay, so we'll do examples of this, but you just have to have a spot where you have a y value. Okay, and then the third step is those two pieces have to equal each other.
How about pencil experiment?
Go ahead. Now, those are the steps to check what? Starts with a C. Continuous, very good, or continuity. So these steps are a repeat that in order for your graph to be differentiable, it has to be continuous first. Okay, so I'm going to put continuous with a little check. Those steps are old. You already did those on test number 1. The new step that you're adding for differentiable is that the left and right derivatives have to come out the same. Okay, so it says, and your LIM x approach a from the left on f prime needs to equal your LIM x approach a from the right. But notice that in that limit, it's not original f, it's the derivative of f. Okay, and they have to equal each other. If they do, then it's continuous and differentiable. Okay? Now let's talk about what types of things would make a function not differentiable if you're looking at a graph. So there are 4 indicators. Okay, you'll see them over here on the side. If it's not continuous, it's automatically not differentiable. I'm going to draw all 3 types. You could have a hole. Bless you. You could have a jump. Or you could have an asymptote. Okay, but any disconnects in the graph, remember, automatically it can't be differentiable because how could you draw a tangent line? It can't fit both sides. So any discontinuity is automatically not differentiable. Okay, draw yourself a cusp and a corner. Okay, a cusp is just where at least one side is a curve, versus a corner would be like an absolute value graph where both sides are linear. Okay, but cusps and corners also are problematic because you can't draw a tangent line that's going to match both sides. The final option is if your graph goes vertical. Okay, so draw me a vertical tangent where it magically goes straight up and then keeps going. Remember, the problem with a vertical tangent is you can draw the tangent line, but then when you try to find its slope, it comes out undefined. Okay? So those are the features that make a graph automatically not differentiable. Okay? Last 2 things that we covered in this unit. Okay, for an equation of a tangent line, you have 2 ingredients that you have to find. The first one is the point. So I'm going to put x1, y1. And then the second one is your slope, which we've been calling m. Now, your slope comes from plugging x into which equation? The original or the derivative for slope? Derivative. So I'm going to put right here, you're using f of x for the point. You're using f prime of x for the slope. Okay, and we'll do examples of all of these here in a minute. Once you have those ingredients, it's y blank equals blank x blank. Remember, the x and the y go in reverse signs. Your m will go in with its actual sign. So minus on the y1, minus on the x1, regular on the m. Okay? All right, the last thing that we talked about in this unit is the limit definition of a derivative. Okay, remember, you do not have to be able to work these out the long way. Okay, all that you have to do is recognize that LIM, h approach 0, of f of x plus h minus f of x over h means take the derivative. So all that you're going to do is circle the function, not the minus. You're circling what's behind the minus, and then you're just going to take the derivative. Okay, so I'm going to put here, take derivative using your deriv rules. Okay, on the AP test, they're not going to ask you to work one of those out the long way. So you just have to know whatever's behind the minus, if h is going to 0, I'm taking the derivative of that. Okay? So to kick us off, we're going to do first half of the review, do a little bit of it together. Then we'll let y'all work for a bit. Then we'll go to second half. We're going to work these limit questions. I deleted them off last time's homework, and I just put them on your review. So turn to number 13. These should be super easy. All you have to do is circle f of x and take the derivative. So taking a look at number 13, remember f is behind the minus. So on 13, this is my f, and you're just going to take the derivative. Okay, what's the derivative of that? Yes? And will the x stay? No, because you got to bump the power down. You're done. Okay, let's do one more. Let's do number 17. What's behind the minus? 2 cosine. What's the derivative of cosine?
Negative sine.
Negative 2 sine x. Okay, very good. Last one we're going to do from this is 16. You'll notice that on number 16, what sign is in the middle? A plus, and what should it be?
Negative.
So this is really minus negative 4 ln x. And then you're going to circle and take the derivative. So if it's a plus, that's a trick. That it was really minus a negative, which means I want the derivative of minus 4 ln x. Look on your sheet if you need to. What's the derivative of ln x? 1 over x. So that would go to negative 4 over x.
4
Uh-huh.
times 1 over.
Uh-huh. Perfect. Negative 4 over x. All right, we're going to work a couple more examples from this same section. Okay, but we've spent quite a bit of time on this, so I don't want to do a million of these together. Let's start with number 12. Okay, and I'm going to try to pick the ones that look harder. Number 12, it is in radical form. So you are going to need to turn it into rational exponent form. So rewrite. What is the power going to be on square root x cubed? 3 over 2 is correct. Okay, remember, it's power over root. So that's a cubic power over a square root. Okay, for my next term, what is the coefficient or the number in front of x? Is it just a 2?
1/2.
1/2. Very good. This is a 1 over 2. And then my x, since it's in a square root, would go to a half. Now, keep in mind, I haven't taken the derivative. I just rewrote it. Now we're going to take the derivative. So my f is going to turn into an f prime. What is 3/2 times negative 2? So negative 2 times 3 would be negative 6 over 2, which is negative 3. Okay? From there, you're going to take away 1, but you're going to do it with a compatible fraction. Uh-huh, so it's going to be 3/2, take away 2/2 would be x to the 1/2, which I'm going to then turn into a square root. Okay? Next term, I have a half times a minus a half. What's that? 1 over 4. Because remember, you times the tops together. 1 times 1 is 1. 2 times 2 is 4. But then I have to minus 2 halves. What's 1 half minus 2 halves? Negative 1 half. And then remember, minus powers go on the bottom. So if it's a half, it's a square root, but it's going to join the 4 on the bottom. Okay? Then from there, that's f prime at any x that I want. Where am I asked to take the derivative at? F prime of 3. So I'm going to put at x equals 3. And then plug that in. All right. Okay, so let's do it. We're going to have, okay, let's try to lock in here. We have a test next class. Negative 3 root 3 minus 1 over 4 root 3. Okay, you need to get your almost, I think your entire test is multiple choice, pretty much. There's maybe 1 or 2 where you'll have to show work. So your answer choices are going to be just like on delta math, that it has to be one fraction. So if this has a 4 root 3 on the bottom, what does this one need?
4 root 3 on.
So you're going to put a 4 root 3 here, which means you have to also multiply it here. So let's review how that's going to look. What is my 4 times my 3 for the regular numbers? 12. Negative 12, thank you. And then what's root 3 times root 3 again?
3.
Regular 3. And then what's negative 12 times 3? Negative 36. Okay, they're both over a 4 root 3 because now the bottoms match.
Oh, we're being recorded again.
You are being recorded.
Hi, guys.
Good. Okay, so one more time on this part. Root 3 times root 3 goes to a regular 3. 4 times 3 is 12. Multiply those together. That's where the 36 came from. Okay, then negative 36 minus 1 more is negative 37 over 4 root 3. Okay, for your final answer. Okay. All right. Number 11, can you do your rewrite for me? Right next to it. All right, so rewrite. What is it going to be? Somebody tell me.
8x to the 3 over 2.
Ooh.
Minus
Okay.
6x to the negative 1 half.
Yes, very good.
Yes, guys. Come on, let's do it.
Okay, very good. Take the derivative.
Oh.
Okay, so 3 over 2 times 8. You're going to do 3 times 8 is
24.
24. Then divided by 2 would be
12.
a 12 in
X,
front.
2x and then 1 over 2.
Uh-huh. Because 3 halves take away 2 halves leaves you with 1 half. Okay, next one, I have a negative a half times a negative 6.
Negative 3.
Plus or minus 3? Plus, because it's a negative half times a negative 6.
Oh.
And then what's minus a half? Minus 2 more halves. Negative 3 halves. Okay, then from there, your answer choices are going to be in radical form. So where will my square root go at the 12? Next to it or below it?
Next to it.
Next to it. Where will the second one go? Next to the 3 or below the 3? Very good. Okay. Now notice that for number 11, you're not asked to plug in a number. That makes it a little bit easier. Your test will be the same way. Some of them you're just taking the derivative. Some of them you're taking the derivative and plugging in. Okay, go back 1 page. Okay, let's take a look at number 6. Number 6, write RW. What's it stand for? Rewrite.
In a minute, I'm filling up your water.
Okay, you're going to do 3x5 plus 5x squared minus 1. But if they're all divided by x squared together, then I'm going to divide them all by x squared separately. Remember, the point of me doing this is that I can get each term into just a regular power that I can then take the derivative of. For my first term, how many x's will be left if it's an x5 divided by an x squared? x3. Now, for my 5, I had an x squared, but I'm dividing an x squared, so what's left? Just a 5. And then for my third term, the only x's I have are on the bottom, so to pull them up, what do I have to do to the squared? Turn it negative. Very good. Now notice, I haven't taken the derivative yet. I'm prepping it to take the derivative, which is my next step. So I'm going to write that this is still f of x, and now we're taking the derivative. Okay? Go ahead and do that for me. Regular power rule here. So 3 times 3 is? 9x squared. What happens to the plus 5 if it's a constant? 0. And then negative 2 times negative 1 becomes a plus 2. What's the new power on x to the minus 2 if I take away one more? Minus 3. Okay, then remember, you won't see answer choices with negative exponents. So it'd be 9x squared plus 2 over x cubed. Okay? Do you want to do one more off this page, or you feel good about it? One more, maybe 3 or 7? 7, okay. Will you rewrite it? 6 is going to be, 6 and 5 are very similar. Okay, what's your rewrite going to be? Okay, what's my rewrite going to be here? X to the what? Remember, it's power over root. To the 2/3. Very good. Okay. Then from there, we're going to take the derivative. So f is going to turn into f prime of x. What is 2/3 times 2? Remember, 2 is like a 2 over 1. So times the tops times the bottoms.
4/3.
4/3. And then in order for me to minus 1, I'm going to minus 3/3 because I'm measuring 2/3. Take away 3/3 would be what? 1/3. Okay, what happens to the minus 3?
Disappears.
Very good. Okay, from here, I have a 4 over 3. X to the 3rd is a cubic root. Where does it go? Top or bottom? Bottom. Okay, that's my derivative at any x. Then I do have to plug in what number here? 27. What is the cubic root of 27? It is 3. So cubic root of 27 is 3. Times it with the other 3 on the bottom. Answer is 4/9. Okay. Number 4, will you rewrite it for me? And then we're going to move to next section. Number 4, do the rewrite on it just to make sure you do it correctly.
Yeah, we might have to require you. Oh, yeah.
Okay, somebody want to tell me your rewrite? Okay, what is the first term supposed to say? Minus 2x to the 4? Is that right?
Oh.
1/2. Remember, that 2 cannot move up. So that's a minus 1/2 in front, x4, minus 3x. What am I going to do with the 10 over x?
We're going to move the x to the top, so it'll be 10, negative, yeah,
negative 1. Very good. And on the next term, my x3 would move up, so it'd be a minus 4x minus 3. Okay? Then from there, you're going to take the derivative and rewrite it back, push those x's back down. All right, we're going to move on to the tangent lines section. Okay, so if you'll turn ahead for me, please, to let's do number 23. Or actually, maybe we'll do, yeah, 23. Okay, 23 says we want to find the values of x where the function has a tangent slope of 2. If I want the slope to be 2, what is my game plan? Take the, starts with a D, derivative, and then set the derivative equal to 2. Now, you're setting it equal to the slope that you want. Okay, but if I want the slope to be 2, I'm going to set it equal to that number. So go ahead for me, please, and take the derivative. Okay, nice, easy power rule here. So 3 times 3 is a 9x squared. Next term? 12x. Next term? Minus 10. What happens to the 1? Set it equal to 2. Now, from here, if you are asked to factor, you got to get everything on the same side. It has to equal 0. So I'm going to subtract my 2 across from my 10 so that I have 9x squared plus 12x minus 12. Before IAC chart, what would make this easier? Divide everything by 3. Okay, if all of them can divide, you should do it. It'll just make your AC number a lot smaller, which will give you less numbers to look at. So I'm going to have a 3x squared. 4 divided by 3 is a 12x. And, oh wait, wrong, 4x, thank you. And then minus 12 divided by 3 is a minus 4. Label your ABC. Which means that we're doing A times C, remember air conditioner at the top, basement on the bottom. Negative 12. My basement number is a 4. And then what are the partners that will multiply to 12? Okay, so 1, 12, I heard 2 and 6, also 3 and 4. But I need numbers that will add or subtract to 4. Which one? Okay, good. I have to use subtraction because the top of the chart is a minus.
Miss Jordan, do you make these the questions for the test?
Yeah.
You should make one where the answer is 6, 7.
Ooh, okay. Challenge accepted. So 2 and 6 are my guys, but I want to keep my 4 positive, so I'm going to put the minus on the 2 side. Okay, from here, remember that if your A is a 1, okay, if your A is a 1, you can go straight to your factors. Is my A a 1 here? No, so you're going to have to do grouping. So you would keep the 3x squared the same, but your 4x in the middle is going to go to a minus 2x and a plus 6x. Okay, or if you remember how to slide and divide, some pre-cal teachers teach that, you could do that too. But grouping is how most of the pre-cals teach it. What do the first two have in common? Not a 2x, just in x. So that'd be x out would be a 3x minus 2. Second partners, what can I take out? 2. My 2 comes out. That leaves me with another 3x minus 2. Remember, these have to match. If they don't match, you messed up, which they do, so that's good. 3x minus 2 is my first factor. What's my second factor? X plus 2. Okay, then from there, you should be able to identify your x values. Remember, they're the opposites of what came up in the parentheses. So if it's an x plus 2, that means x equals minus 2. And then for the 3x minus 2, do you remember what it would be? Yes, good. Okay, the minus 2 turns positive, and then the 3 would just slide to the bottom. Okay, but remember, you only have to do this crap if your A is not a 1. If your A is a 1, you just write the parentheses, get the answer right away. Okay? Now, I'm not going to do 22, but if I want a horizontal tangent, what slope are they asking me to find? What number? Horizontal tangent. 0. So you're going to take the derivative and then set it equal to 0. Okay, so remember, a horizontal is just a specifically 0 slope. So you solve it the same way, but instead of letting it equal 2, you would let it equal that. Okay? All right, we're going to do one more question together. Turn the page. And let's do number 26. Yep. 26. You are asked to write the equation of a tangent line. Okay. What are your 2 ingredients that you need for the equation of a line? Very good. Remember, you have it on your cheat sheet, a point and a slope. Okay, they've already told me my x value is a 9, so it's 9 comma something. To get the other half of the point, I plug into the original. So if it's a 12 minus 4 root x, that's 12 minus 4 root 9. Square root of 9 is 3. Then 12 minus 4 times 3, 12 minus 12, which is 0. So my ordered pair is 9 comma 0. Next thing I need is my slope, which is going to require me to take the derivative. Will I need to do a rewrite? Yes. What's going to need to be rewritten? The square root. So it's 12 minus 4 x to the half. Remember, things that require rewrite are x's in roots and x's on the bottom. If it doesn't have one of those, you shouldn't have to rewrite. So roots and x's on bottom. Okay, let's take the derivative. F to f prime. What's the derivative of 12?
0.
Good. What about minus 4x to the half?
2.
Yes.
X to the negative.
Ooh, let him cook. Good, good. Okay, then my minus a half power needs to go back where? To the bottom. So remember, a half is a square root. The negative places it under the 2 instead of next to it. Now, that's my slope anywhere. Where do I want my slope at? What number?
9.
9, so I'm going to plug it in. So at x equals 9, that's going to give me negative 2 over root 9, which is negative 2/3. Now that I have my point and my slope, all I have to do is write my equation. So remember, it's y blank equals blank x blank. The x and y's go in opposite signs, slope goes in true sign. So negative 2/3 is going to go here. Minus 9 will go here. Minus 0 will go here.
We have to put.
You do not. And for your tests, remember what I said is it's multiple choice. So if your answers are not in point slope form, but they're in y equals mx plus b, remember it's very easy to switch. You're just going to multiply this in. So what's negative 2/3 times x? Negative 2/3 x. What about negative 2/3 times negative 9? Positive. What's 2 times 9? 18, then divide by 3. 6. Then, if this wasn't a 0, you would just add it across. But since it is a 0, this would be your answer. Okay, so some of your questions will leave the answer in point slope, like that. Okay, but both of those are correct. You'll just have to look at your answers. Okay? All right, this is a good stopping point. Okay, you are not having free time, you're having time to work on this. So we're gonna pick up at 29, but I'm gonna give you like 20 minutes to kind of work on your own. Okay? Ask me if you need help.
You guys step outside real quick?
Sure.
Oh, we're working on 29?
You want to work on the first half.
Oh.
So 1 through 28, do whatever we didn't do together.
20 plus 20.
I mean, you may not finish all of it, but you know, you have time.
Okay, playing for
Like you don't have to think you missed 2 days. So then the main thing you miss, it's actually the same notes twice, because we did it for 2 days and it's the same homework. But it's all of the 1/2 wherever you would see the queuing. So I would say, I'm okay with you bridging your test a little bit, but it's like, because it's like the end of the quarter gap. So why don't you do these notes? I will tell you the first day, the video is an hour and a half. So when we go to work on homework, just end the video. And I don't ever like come back. I just forgot to turn it off. Okay? And then I would say just try to get maybe by the end of the week if you can. But it's a longer notes, which is why we did it in 2 days. Okay? Yes. All right, Alberto, we're ready to do our review. What is this? This doesn't look very calculus.
Final? Oh, why?
Yeah, a little white noise is fine as long as you're working. Yes.
What?
You went?
Let me try to help real quick.
Okay, I'm gonna listen in.
Oh, define a derivative. 4 times 3. 4 times 2. 4 times 10.
Yeah, you don't need those most, honey. You can't even use the calculator on the test.
Right here, I have 12 times 8.
Oh, okay. I won't give you one that big, but 12 times 8 is 96. And you're right, that one does come out a little bit bigger.
Okay. And then what do? You have x minus that.
Yes, ma'am. I think so. Let me look. Number 5.
It doesn't have to be component. It's a booklet.
Yes, that is correct. Good job, Asha.
Oh wait, we didn't have the derivatives yet.
All right, go ahead and finish up the one you're working on. I don't want to rush you, but I just don't want to have to record forever. So finish up what you're working on, and then we're going to pick up on number 29-ish. Okay?
Okay. So basically, we got this one, so that we can and
all right, number 29. Let's go ahead and turn there, please. Yes, sir.
2 minutes, a minute and a half.
Okay, sure.
Yeah. So now we have to find the derivative. 3. Then negative 9, and then you have to subtract it.
Yeah. 29. That's what we're going to pick up. Mauricio, this is your old test review. Allie, this is your old test review. Hey, pictures.
Oh, been doing that here, testing me because I never found one.
From the first test?
Yeah. And I also have a 0 for that.
Yes, it's been in there for a while, Rodrigo.
I was almost absent that day.
Okay. I think I still have some.
There you go.
Yeah. If you wanna complete the one you skipped in there, I can use it. Thanks.
And 4 times 2.
Oh, Rodrigo, there's your old quiz back.
Damn.
Alright, Rodrigo, are we almost ready?
Yes, we're just gonna rewrite and then plug in and then. Negative, what is it, negative 4, right? Then we rewrite, negative 9 over. Excellent 1D. Plus. And then we plug it into 1. So, negative 9 over. Negative 1 plus 8.
No, I'm listening. You're good. You're good.
Then.
I told him I'd wait.
1.
Y'all go ahead and do 29 and then we'll check in a sec. So you want not differentiable.
So, negative 1 to the 4, right? Plus negative 1, negative 1, positive 1. That's the negative 1, that's another negative 1, positive.
So how did your 9 come out?
There's gonna come out negative 9 over 1.
Okay, which is just negative 9. Yep, that's right.
Plus negative 8.
Uh-huh.
And 9 plus negative 8. Negative 17.
Yes, that's right. Very good. All right, number 29. You are asked to find where the graph is not differentiable. There are 2 spots. Can you tell me one?
0.
0. What's the type?
A jump.
Okay, it is a jump. I'm just going to put discontinuous. Okay, but jump is the type of discontinuity, which is also correct. Okay, what other feature?
2.
2 is a what?
A vertical.
Vertical tangent. Very good. Now notice it's not a vertical asymptote. Okay, vertical tangent means that you can draw the line laying perfectly next to the curve, but its slope happens to be undefined or vertical. Okay? All right, the instructions for 31 go with the graphs on the back of that page. So for 31 down there at the bottom, I'm just going to put an arrow. Okay, all that you're going to do is list what the features are. So will you do it on the top of the next page? Okay, and you should have one of each type. So for 31, I'm just drawing a little arrow. We're going to list the types. Graph number 1, what is it?
A plus.
Cusp is correct.
And then 40.
Okay, number 2 is a corner, correct.
Vertical tangent.
Yep. Vertical tangent, and then the last one is a jump or a discontinuity. Okay. Now, out of those 4 types, if the question said it had to be continuous but not differentiable, which one would you have to throw out? Continuous but not differentiable.
Vertical.
Is that one still continuous? What about this one? What about this one? This one would not be. Okay, so remember, there are 2 ways they can ask that. Where is it not differentiable? Or where is it continuous but not differentiable? You should be prepared to answer both of those just like on the homework. Okay, we're going to do 33. It asks you to use the definition. So look at your little sheet. Your definition's right here. The first thing I'm going to check is that it's continuous. Then if it's continuous, I'm going to check that it's differentiable. Okay, but remember, it's 2 steps to check that. So let's start with the limit from the left and the limit from the right. What is my breakpoint number? 0. So I'm going to do 0 from the left and then 0 from the right. Remember, these are supposed to match each other. A left limit, you're doing less than 0. So is that the top or the bottom piece here? A left limit is less than 0. Is that top or bottom? Top. So it'd be 2e0 plus 7. What is anything to the 0? 1. 2 times 1 is still 2, plus 7 is 9. Okay, right side limit. For a right side limit, you want greater than, which would be the bottom. So I have 9 cosine 0 plus 2 times 0. Which one is your 0 finger on your left hand? Pinky. How many fingers are up for cosine? 4. Then I square root 4, which is divided by 2. So 1. 9 times 1 is 9. 2 times 0 is 0. 9 plus 0 is 9. Did my left and right limits match? Yes. The next thing that you have to check is that you have a y value. Remember, this could be its own piece, or it could be built in to the greater than or less than as an equal to. Where am I built in here? Top or bottom? Bottom has the equal to, which means the answer is still 9. So for part 2, yes, sir?
I kind of got lost. At the negative, at the plugging in the wood right there.
So cosine of 0 is your pinky. Cosines
At the top.
here.
Yeah.
Anything to the 0 is 1.
Think it's 0.
So if it's 5 to the 0, it's 1. E to the 0 is 1. Then you times it by 2.
We'll put plugging in 0. Oh.
That's right.
So anything to the 0?
Anything to the 0 is 1.
1, okay.
Uh-huh.
So 2 times 1, or would it be?
2 times 1.
2 plus 7? Oh yeah.
Very good. All right, your third step, you have to have a limit. Okay, you have to have a y value. They have to match, do they? Yes, if you are asked, okay, if you are asked to check that they match, you need to state that, okay? Even though it's obvious, I see the 9s on your paper. That's the third step because you're using the definition. Okay? So I'm going to put continuous check. What were you going to say, Rodrigo?
They're both equal, so then that means it's good.
Now, after it's continuous, that means it might be differentiable. So after it's continuous, I'm going to take the derivative, which is going to require me to take the derivative of both pieces. The top piece is a 2e to the x. What's the derivative? Ln goes to 1 over x. What's e to the x? E to the x again. Okay, but what's going to happen to the plus 7 when I take the derivative? 0. Okay, on bottom, I have a 9 cosine x. What's the derivative of cosine? Negative 9 sine x. And the 2x, will anything stay? Plus 2. Okay, then remember, I want to check the left and right sides. So it'll be LIM, x approach 0 from the left, and then LIM, x approach 0 from the right. Okay, for this question, if I were you and I did this on my test, I would miss a point here if it was written out. What did I do wrong? The derivative, you have to put a prime, that's correct. Okay, so remember, I'm not plugging into f, I'm plugging into f. That would be 2e to the 0. What's anything to the 0? 2 times 1 is 2. So my left side derivative is 2. Now let's check our right side. It'd be -9 times the sine of 0 plus 2. Find your 0 finger, still your pinky, but you're counting down. How many fingers below your pinky? None. So this is going to be a 0. That's going to eliminate the 9 and give you 2 again. So my left and right derivatives are the same, then it's continuous and differentiable. Okay?
Part of the interruption.
All right, turn the page.
Just a reminder, if you are planning to have a guest come to homecoming this weekend, they need to have a form. If you need a form, please come to office 1 to pick it up. Once again, if you have a guest coming to homecoming, please ensure you have filled out the form that is available in office 1. Thank you.
All right, last one we're doing is 35. Okay, if you want to make the function differentiable, I put the steps for this on your cheat sheet. Okay, let me draw your attention to it. Okay, right here, to make it differentiable, it has to be continuous. So you're going to let left equal right. Then to make it differentiable, you're going to set derivative left and derivative right equal. Okay, and then solve. So let's do it. For continuous, I'm letting left equal right. And then L prime equal R prime. Okay, let's do the originals first. So I have an ax squared plus 10 equal to an x squared minus bx. What is my x value or my breakpoint that I'm plugging in? At x equals 2. So I'm going to have an a times 2 squared plus 10 and a 2 squared minus b times 2. Okay, go ahead and work that out. What is 2 squared? So this is a 4a. 2 squared is 4 minus b times 2 is 2b. Okay, then you kind of get stuck. You have an a, you have a b, but now we're going to go to the other side. Let's take the derivatives. What is the derivative of ax squared? Very good. 2 times a is 2a. X squared becomes a regular x. What happens to my 10?
Disappears.
Okay, equal to, what's the derivative of x squared on the bottom?
2x.
Minus b. Very good, because remember, that's a bx to the 1. So 1 times b is b, and then the x drops off. Okay, then remember again, x equals 2. So this is 2a times 2, 2 times 2 minus b. Okay, from there, 2a times 2 is 4a. 4 minus b. And then when you get to this step, you want to pick either equation, it doesn't matter, to solve it for a letter. Now, this b being almost alone, that's my guy. So how can I get rid of this 4?
Minus. Or divide. No,
Not divide.
minus.
Minus it. So I'm going to minus 4 on both sides. So now I have negative b is a 4a minus 4. Now it's almost alone, but that negative's got to go as well. So if I just change all the signs, I would have a negative 4a and a positive 4. And that's what I'm going to use to sub into the other b, correct? So you're going to pick a side, get one of the letters alone, and then use it as a substitute on the second side. So this is going to be 4a plus 10 equals 4 minus 2. And then where my b was, I'm plugging in the negative 4a plus.
If you distribute a negative.
That's right. So I'd have 4a plus 10. 4 negative 2 times negative 4a is what?
Positive 8.
Positive 8a, and then negative 2 times 4 is a minus 8. Okay, I'm going to draw my railroad tracks just because I think it's adorable. Okay, do you want to have to do? Okay, remember, numbers on the same side of the tracks, you can just add them up. So the 4 and the -8 is how many? Okay, -4. So I'm just combining those two. Okay, then from there, you want to bring one of the A's across. I usually will move the smaller one, but really it doesn't matter. So I'm going to minus the 4 A's over. What is 8A take away 4A? 4A minus 4. What's my next step? Add the 4 to both sides. 10 plus 4 is 14 equals 4A. Last step, divide by 4 on both sides.
Wait,
Uh-huh.
oh, we minus. 4A.
So my A is 14 over 4, which we can reduce to 7 over 2. Now that I know what A is, I can go back and find B by just subbing that number into this spot. So my B answer is -4 times A, which is a 7 over 2, plus 4. Okay, remember, if 4 is a whole number, what number goes on bottom for me to times those fractions? A 1. So 4 times 7 on top is a 28. Divided by 1 times 2 is 2. What's 28 divided by 2?
14?
Uh-huh. -14 plus 4 means my B is a minus 10. Okay? Questions on that?
Nope.
Okay, you only have to do this substitution step if when you take your derivatives, one of the letters doesn't go away to give you a clear answer. Okay? All right, ask me if you have any questions. The key is on Schoology. Okay, and then your test is on Thursday. Remember, if your review's not ready to turn in when you get to class, you get 10 points off. So instead of 100, you get a 90. So let's try to get it finished before 7th period. Okay, and you're welcome to come to advisory if you need help with anything. Just put in a pass.
I feel like I'm getting this a little bit more than the first.
Yeah.
Really? Limits are kind of